Well, all right. So these are among the big changes that we've seen unfold in the Arctic over the past several decades. So how did this all happen? When did this all start? Right? Everything has a start to it. So when did the Arctic begin to stir? That's the question. Well, it took a while. This, despite that 1960s cooling, right, that led to my master's degree, there was growing acceptance that as we increased the load of carbon dioxide in the atmosphere, things would warm up. But even by 1990, when that first IPC assessment came out, the Intergovernmental Panel on Climate Change, right, the first assessment came out, the evidence was spotty, right? We thought we'd start to warm up, but the evidence that was there was really pretty spotty, especially in terms of the Arctic. So now I put this figure in here because this is a map of temperature changes across the Arctic. So if your geography here, I think you can recognize part of the United States, okay, on there in Greenland, and then of course on the other side, Vladimir Putin's territory, right? This is a map of temperature change from 1960 through like the mid-1980s, I think through 1986 it is, right? And just looking at that temperature change, I showed you a map before, right? This is just from 1960 to about 1986. The areas in red is where it was warming. The areas in blue where it was cooling. What do you see? A mix, right? Some areas warming, some areas cooling. Exactly the sort of thing we just expect from good old climate variability, right? Just like, right, here in New York, you might have a winter where it's really cold and you get a lot of snow, right? And the next one is much warmer and it's just rain or something like that. That's just the natural climate variability inherent to this system. It's always been there and always will be with us, right? And back then, we were just looked to me like we were just looking at that kind of variability. Some areas warming, some areas cooling. You'd have changes in atmospheric circulation, bringing in warm air one area, cool air in another. Okay. In other words, nothing really to write home about. Right. That's what we were looking at then. What were people in the climate community talking about? I talked about, going forward a couple of years. I said, well, tell me what was going on in like 1991, 92 from your perspective. So here's Jim Overland. He's NOAA, so he's back at work now, right? And he's been doing climate research since the 1970s. He started out way before I did, right? We've written a few papers together. He said in 1991, 92, we did not see or think much about Arctic changes, right? It was all variability. Marika Holland, a close colleague of mine, she's a climate modeler at the National Center for Atmospheric Research, and this in Boulder, Colorado. She was just starting out in her career, and she says she wasn't thinking too much about Arctic change. It seemed like everyone was discussing this future climate, which seemed so far away. She just wasn't seeing. We just weren't seeing it back then in the early 1990s. This change that we certainly expected would come upon us. So I got a little more field experience in about that time, 1991, 92. I was, by this time, a young scientist at University of Colorado, Boulder, NSIDC. And here I was working with some Canadian grad students. We did get some time for play. See, I think my form at golf was quite good there. We had these golf balls, we'd paint them orange or black so that we could see them. It was kind of odd because we were in Polar Bear Alley, was theirs, and so one of us would have the golf club taking their shot, the other one would be watching over with a shotgun, right, that sort of thing. And we had a lot of fun at it, though. I always avoid stereotypes, but there is one stereotype that is true, and it concerns Canadian grad students, right? Is one lesson you learn is never, ever go out drinking with Canadian graduate students, okay? You will live to regret it, right? So this is something I think their tolerance for alcohol was exceeded only by their tolerance for cold. That was my experience, but a lot of them are still close colleagues. But again, we had a lot of fun. And well, what happened? In the June of 1991, Mount Pinatubo blew. And when we were with these students, like in 1991, we came back in 1992 to a different world, okay? Because Mount Pinatubo had blown in June of 91, and we came back to a different world in the Arctic. We never had a summer up there in the Canadian North. We were never had a summer because what Pinatubo had done, right, was put all this gunk high in the stratosphere, right, sulfate aerosols, right, it blew its top. And it was the last thing on our minds. And it was around then, even a year later, where I was author on this paper published in the journal Nature, rather good journal, where what we did was we analyzed temperature data from around the Arctic. We were looking at balloon data, what we called radiosonde data. Right? And this was our conclusion, right? We do not observe the large surface warming trends predicted by models, and we indeed significant cooling trends over parts of the Arctic. Wow, where's the global warming, right? Not here, right? Not from the data that we've been collecting. We went up there after Pinatubo, my gosh, right? It was sort of the summer without a summer. It was crazy, right? But that's the way that we were thinking, a lot of us were thinking. But hints started to emerge. And the first hints that the Arctic really was starting to warm up came not from air temperatures, but a warming ocean. There was a fellow still around, is Detlef Codfossil, well-known oceanographer, Arctic oceanographer. He was on this cruise of the Russian icebreaker Rossiya back in 1991, and he noticed this slight warming of what we call the Arctic Ocean's Atlantic layer. What this is that if you look at the Arctic Ocean and the temperatures, the surface of the Arctic Ocean is quite cold and fresh. Underneath it, there's a warmer layer. Right? And that comes from inflow from the Atlantic. It's warm and salty. And so he collected some data, and he found that, well, it looks different than the data we collected before. Now, he was the first to say that this is only one set of observations. It may mean nothing, right? But let's keep an eye on it. I mentioned he was on the Rossiya, just a little story here. Back in those days, that was just after the Soviet Union had broken up, right? And what they were doing is they were trying to get hard currency, and one of the things they'd do is they'd get tourists out on these big icebreakers. The Rossiya is one of these big nuclear-powered things they've got, and I don't know how many rubles it would cost, a lot, right? They'd take you to the North Pole or something like that, and then you could have champagne or something like that. But what they would usually do on these things, and they still do in some of these Arctic cruises, like with these luxury liners you're seeing going up there, you have a token scientist that goes on, right, that will tell stories and things like that. It's a junket that I've got to get, right, someday. But he was the token scientist, and he collected these data. Didn't look like much, but it got us thinking, could things be changing? A guy named John Walsh, who I've worked with, he started to find some evidence in the 1990s that maybe sea ice is starting to decline. We thought it would, right, because things are going to warm up. One of the most sensitive indicators of that change is going to be the sea ice cover is going to be reduced, right, because we're going to have more melt in summer, less ice growth in winter. And he also started to see changes in patterns of temperature, right? Some areas significantly warming, but some were still cooling. Some were still cooling. So again, were we really seeing a change occur? Or was this just plain old natural variability? We weren't sure, right? There was a lot of people back then, me included, scratching our heads over this. What the heck is going on? Well, the plot then fairly quickly thickened after that. That's a shot from Barrow, Alaska. That's a shore rubble on the sea ice, and you see that little flag out there. That's put out there by the local people up there. They're getting ready for their spring whale hunt. Right? There's a sustainable harvest of bowhead whales, right? And so they were out there scouting and things like that. So we went out to see what they were doing. They didn't want us there because some of us had sort of brightly colored coats. They want you to be in white, right? So to blend in. In any case, the plot thickens. So that Atlantic layer warming, I mentioned this below this cold surface layer in the Arctic, there's a warmer layer that comes in from the Atlantic. It was confirmed. Data collected from the icebreaker, the Swedish icebreaker Odin. Okay, that's the one on the left, kind of an ungainly looking thing. And the Pargo, they confirmed that warming. What the Pargo's a nuclear powered sub, Sturgeon class, I think. And what they had was these cruises, CIRES cruises they called them, in which they would actually have scientists that would go along on these cruises to collect data and things like this. And as part of these cruises, they'd collect all this data on ocean temperature, things like that. So yeah, it looked like that Atlantic layer warming was starting to firm up, right? But the Arctic also now seemed to be changing in other ways as well. Paleoclimate evidence. Paleoclimate is a study of past climates. We have instrumental records of, say, air temperature across the globe that go back to about 1880. You can get them earlier in some areas, but you can get a fairly good record of what the global temperature change has been since about 1880. Well, we would certainly like to know what was going on before then, right? Because you want to have a long record. You want to be able to put the modern era in the perspective of what's happened in the past, right? That's what gives you perspective, right? To tell you if something is really changing. Well, this is what Overpeck and colleagues were doing. So they did a reconstruction going back 400 years. What's this based on? It's based on things like pollen analysis, ice cores. Think about pollen, okay, for example, that you can get from lake cores. Different types of pollen, right, is associated with different types of flowering plants, and those will vary what you've got there depending on the climate, right? That's just one example of the types of evidence, but there's many other types of more. And what he argued, what he found based on his reconstruction is that despite all this uncertainty we had, well, is it really warming? Is some of it cooling? We're not quite sure. He still said from his analysis, despite all this uncertainty that we had, the late 20th century Arctic temperatures were the highest of the past 400 years. So it was starting to say that, okay, we're still not sure what's going on, but according to this analysis, boy, it is really warm right now. It didn't convince everyone that the fingerprint of human-induced change had emerged, but it certainly started to get us thinking in that direction, no doubt about it. More evidence, thinning ice cover. I mentioned those submarine data, right? Well, some of the submarine data, one of the things submarines do when they go into the ice is they have an upward-looking sonar, right? And they use that, and they can tell you how thick the ice is. Right? Actually, it's called, we call draft, which is the part that sticks below the water. Remember, like, 1/10 is above the water, 9/10 is below, because ice is 90% of the density of water. Well, the submarine cruises, most of this was old Cold War stuff, right? Most of it was old Cold War. Some of it was science. Most of it was Cold War stuff. We were doing it. The Russians were doing it, right? And we had these upward-looking sonars on these things. Now, this wasn't because these people collecting these data were thinking some crazy scientists, decades later are going to be using this. It was basically a safety thing, right? They needed to know if they got into trouble, they needed to find a fairly thin place in the ice cover that they could surface, or what we call a lead in the ice cover, an opening in the ice cover. In any case, what this guy, Drew Rothrock, did was that he compared earlier data that had been collected from 1958 to 1976 with more modern records that he was able to get. And a lot of this was stuff that had become declassified. Some of it was, Al Gore actually had a lot to do with that, getting some of this stuff declassified. In any case, so the stuff in the blue was the drafts that we got in the earlier part of the record, 1958, okay? Why that's not auspicious here? That was the Nautilus, right? The Nautilus was our first nuclear-powered submarine, and it did this under ice cruise as part of what they call the International Geophysical Year, but it was basically Cold War stuff, right, to show off our capabilities. In any case, the bars in the blue is from that early data, and they've been put together for just different parts of the Arctic. But just look at that middle one. That middle one is kind of the North Pole region. Well, okay, back in the old days, right, that ice was something like 3.5 to 4 meters thick. Right? Call it 3.5 meters thick, right? That's 12 feet, something like that. You do the conversion, okay? Remember, a little more than 3 feet in a meter. That's typically how thick sea ice can get. And it can get a little thicker than that, depending on where you are. But now the red ones are the ones for the more modern, the later data. A remarkable difference. All of a sudden, it looked like, my gosh, now we've got the data, we're saying that, my gosh, the ice cover is getting thinner. Why would it get thinner? It doesn't grow as much in winter. It melts more in summer. Started to make sense in terms of some of these other changes that we'd seen. So the plot definitely thickened. But still, if you look back on this, it still wasn't clear what was going on. This guy Jim Hurl comes around, then a young scientist at NCAR, National Center for Atmospheric Research. He said that basically everything that we're seeing can be explained by a shift in the patterns of atmospheric circulation, something called the North Atlantic Oscillation. Okay, we don't have to go too deeply into this, but the issue is, we know from just simple observation, right, that the temperature we have, say for a month or something like that, very much depends on just what the wind patterns are, patterns of atmospheric circulation, right? Are you in a cold ridge? Are you in a warm ridge? Are you in a cold trough, right? That cold trough that brings snow and things like that. And this relates right back to the observation, right? Some winters on Long Island are, cold and nasty. Some of them aren't, right? They're warmer, right? Well, what Jim was saying, there had been this shift in what we call the North Atlantic Oscillation. Just think of it as a big pattern of weather variability that just shifted in such a way to bring a bunch of warm air into the Arctic. And that was it. Just a shift in the winds. Well, wait a minute, so how does greenhouse warming fit into this? Didn't have to, right? Didn't have to. We could say that a lot of what we were seeing, whether it be the thinning of the ice cover, the warming that we've seen in some areas, things like that, could just be attributed to a shift in wind patterns, right? No need to invoke the satanic gases, right? Well, wow. So as soon as this study comes out, we're saying, oh my gosh, this is still not clear to us. We are still puzzled by this. Got even worse. A couple years later, this guy, Dave Thompson, he was at Colorado State University, said, well, it's really not even the Arctic Oscillation. It's a fundamental thing called the Arctic Oscillation. Okay, but still, a wind shift, right, is what he was saying. All kinds of studies came out trying to relate everything Arctic to what's going on with the North Atlantic Oscillation and the Arctic Oscillation. It was kind of a feeding frenzy. But, if you look at this, just at face value, it would stay still no need to invoke greenhouse gas rise to understand what we were seeing. And I was sitting on the fence. This is from a paper that I led in the year 2000 in a journal, Climatic Change. And that's what we said in the abstract of the paper. The abstract of a paper, that's just the first part that kind of summarizes it. It said, taken together, these results, what we had done on this is that we had made an effort to take all these different data sets and analyze them for evidence of change, to see what they were doing. And we looked at all these data sets, and we found, yes, there were these coherent patterns of change, less sea ice, general warming, things like this, warming of that Atlantic layer, reduced ice thickness, all those sorts of things. And they were pretty much consistent with each other, but again, as we said here, these results paint a reasonably coherent picture of change, but their interpretation as signals of enhanced greenhouse warming is open to debate. We weren't confused. Now, we still weren't sure. Well, this is how science should work, right? We are trained to be skeptical. We want to see evidence. And when we looked at the evidence, we just weren't seeing it. We weren't seeing that there's clearly a fingerprint of anthropogenic climate change here. We weren't seeing it back then. This is as recently as like the year 2000, right? There's where my skepticism came from. Physics is physics, right? We knew things would eventually have to warm up. You couldn't escape that, right? We've understood the radiative properties of carbon dioxide and other greenhouse gases for a long, long, long time, right? There's nothing new here. But we just hadn't seen the evidence of change. Well, that changed because there was, only a few years later, I would say, an epiphany, using the term of an awakening, right? That's just a shot from a number of our colleagues on the North Slope of Alaska, where I've been doing some work looking at snow surveys and things like that. Sometime around 2004, 2005, maybe 2004, when I turned. And I remember telling myself this, right? I mentioned this North Atlantic Oscillation, Arctic Oscillation, that shift in the winds, right? Which you could express by an index value, as it turns out. I said to myself, if these things regress from their high positive phases, in other words, if the effects of this North Atlantic Oscillation goes away, that's all I'm saying, okay? And the Arctic continues to warm and we still lose the sea ice, things like that, then I'll start to be convinced, right? That is what will turn me. And that is exactly what happened. Sometime just a few years after that paper I published, that this influence of the North Atlantic Oscillation regressed. In other words, that wind pattern slacked. Right? It wasn't really there anymore, driving that warming. But did the warming go away? Right? Did the sea ice loss go away? No. It remained and it became ever stronger. That's what turned me. It was really just the overwhelming weight of evidence that turned me. Since then, I kind of turned hard, right? And ever since then, I've become fairly outspoken on the issue of climate change from an Arctic perspective, because we'd always figured in the Arctic is where we're going to see it first and where it's going to be most pronounced, and that is just what has happened. Ever since then, it's just been a series of kind of, I'd say, rude awakenings. September 2007, right? All right, here's the sea ice cover for a number of different years in September, right? I mentioned that's the sea ice minimum. You see on the yellow line, that's the median extent over the period 1979 to 2000. That's basically where it ought to extend to in a typical year, basically. Then the green one, you may not see it so well in the back there, but that's what we saw in 2005. Now, when that happened in 2005, the sea ice that was a record low at the time. It was a record low at the time. And we were like, wow, a record low sea ice cover. We'd never seen anything like this. 2007 comes along and just blows it away. It didn't just beat the old record, it blew it away. And I remember, what was happening back then is through the late summer of that year that the science community, the climate science community was just looking every day at these huge chunks of ice being eaten away. What you do is you turn on your computer and you go to our website where we track this stuff on a daily basis, and you can just look at this. And we were just shocked that what we were seeing, we'd never seen anything like this. I think 2007 was a very kind of a watershed year. I think in terms of the sort of polar science community, it was the year that any last doubts that a new Arctic, a brave new Arctic, if you will, was upon us, were gone at that point. Any remaining shred of doubt was gone at that point after we saw what happened in 2007. I mentioned that issue of Arctic amplification, right? That the Arctic, we figured was the place where it's going to warm up the strongest, right? Quickly and most the strongest, in large part due to these feedback mechanisms. Like I talked about that albedo feedback, I think. Now, the figure on the left is just the one I showed much earlier, right? The one that goes from 1960 through 1986. Some warming, some cooling, the sort of thing that you just expect from the natural variability in the climate system. What do we see when we look at the more modern period, 1987 to 2016? It's all red and bright red. Arctic amplification is here, right? It just goes to show you how things really changed. Wild cards out there, things we're looking at now. You've probably heard of this. This idea that a warming Arctic can actually have influences on weather patterns in middle latitudes. These are the sort of things we're looking at now. How does this work? Well, you just think about how the weather machine works. Why we have weather, why we have storms and warm fronts and cold fronts, is that the atmosphere is always trying to do its job of transporting heat from the lower latitudes where it's warm to the higher latitudes where it's cold, right? What happens, of course, is the sun don't shine as strongly in the Arctic as it does in middle and lower latitudes. That sets up a big temperature gradient in the atmosphere, big pressure gradient in the atmosphere. The job of the atmospheric circulation, weather, is to transport heat from the low to the high latitudes. Well, if we warm up the Arctic strongly, like we are through Arctic amplification, you're basically messing with that temperature gradient. So the argument is that we can have shifts in the jet stream, very wavy patterns, so that, for example, at the same time that Chicago's in a deep freeze, out in Alaska it's so warm they got to change the start of the Iditarod, things like that, okay? Still controversial. Some scientists say, absolutely I see this, right? Some scientists say, I'm not so sure, but it's a big area of research. Permafrost carbon feedback. That's another one people are looking at. If you look at these carbon, the Arctic, it's underlain by permafrost, but that permafrost has a bunch of carbon in it, right? Old peatlands, things like that, that's frozen. You warm up the permafrost starts to thaw, the little critters, the microbes in the soil become active. What do? They breathe. What do they breathe out? Carbon dioxide. or methane, depending on whether it's an aerobic or an anaerobic process, increasing the atmospheric load of carbon dioxide to further the warming. It's a nasty one out there because once the genie is out of the bottle on something like this, you really can't stick it back in. Questions. When will this kick in? How strong will it be? Will it kick in 20 years? And if so, will it be a little thing or will it be a very strong thing? We don't know. Right? The Arctic has gotten the attention of our government. The US Navy is all over this. I've talked to Navy people. They say, I don't care why we're losing the sea ice cover. What I see is I have a blue ocean now I didn't have before. I've got to deal with it. Right? Navy's put out a new roadmap to prepare themselves for this new Arctic with much less sea ice in it. We can go forward. Commercial shipping we're starting to see happening in the Arctic. Maersk, right? The biggest shipping companies in the world. They send their first cargo ship through what we call the Northern Sea Route. That's the route along the coast of Russia that would normally be closed, but now with less sea ice, it's navigable. Now, the Russians have been operating up there for a long time, but now you're seeing it regularly open towards the end of summer. You can get ships through there, right? Maersk says it's just experimental. Reuters News, they're saying, well, maybe this is going to become a mini Suez Canal. Because you can imagine, for example, you've got your boatload of Toyota Priuses, right? And instead of going through the Suez Canal or the Panama Canal, whatever route you need to do, you take it right across the Arctic Ocean because you've got less sea ice there and you can do it, right? It's savings of food, savings of fuel, which means savings of cost, right? This is actually happening now. Tourism. Hey? You may have heard of the Crystal Serenity that went through the Arctic Ocean summers of 2016 and 2017. They went through the Northwest Passage, what we call Amundsen's route of the Northwest Passage. Yes, Amundsen conquered the Northwest Passage way long time ago, back in the early 1900s, but it took him and his hardy crew 2.5 years to do it. The Crystal Serenity went through there without a hitch in a week. Right? Big cruise liner, okay? It's like 68,000 gross tons, 820 feet. This is like aircraft carrier size, even bigger, right? I think the berths are like something like 40,000 a pop or something like that, right? You can go through there, raise awareness of climate change or something. This is the junket I got to get on, right? To be the featured scientist that can go on that, right? We'll see. I'm going to try and write him a letter soon. But you're seeing that. Resurgent Russia, right? Russia's capabilities in the Arctic are way, way ahead of ours. Now, they've been operating, of course, along the Russian coast, which is Arctic, for a long, 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 long time, right? So you'd expect they have good capabilities, but they're way ahead of anything we've got. We've got something like 1.5 icebreakers in the U.S. We've got the Healy, which is fairly young. Then we've got the Polar Star, which is kind of not there. Canada's not doing that much better. The Russians have a huge fleet. And they've even got these huge nuclear-powered things, like the Arctica. There was the old Arctica, which was the run on the red. Recently, they launched the new Arctica. This is something like 140 meter long, I think, twin nuclear generators on it. It can go through anything, right? So researchers, but why is Russia so much after these things? Right? So interested. Resource extraction, right? That's one of the big drivers. What we found is that there's a lot of oil and natural gas at the Arctic Ocean seafloor. And now, with less ice, it is becoming more accessible, right? Russia's already all over this, right? Okay, we've got our own resources in north of Alaska in the Bering Sea. Of course, we've been drilling along the North Slope, right, for a long time, right, Prudhoe Bay area, but now we're starting to go out further into the ocean, the Beaufort Sea, maybe into the Chukchi Sea. There's been a lot of exploration activities, but yeah, it's a matter of price, right? Will it be economically feasible to do this? The Russians are saying, hey, it is for us, for sure, right? With us to go offshore, it's not quite clear. It depends on what oil and natural gas prices are, things like that. But it's just interesting how the issue of climate change in the Arctic, climate change and geopolitics have just gotten like that up there. It's you're seeing doctoral theses written on this very sort of topic because it's just sort of this great experiment, not I shouldn't say great experiment, but this experiment that's now unfolding before our eyes of how climate change and geopolitics start to interact with each other, and we're seeing it in the Arctic. So to end this whole thing, you know, if you look, I go back to those little ice caps that I became so familiar with back then. I mean, I knew every square inch of these ice caps back then. I kind of called them my ice caps. They were the Canadian government's ice caps, but you know, I thought of them as mine. But I think back to them almost every day, and they are just inconsequential victims, right? It's just a drop in the bucket for sea level rise or something like that. You know, nobody else is going to miss them, but I do. And you know, I'd like to go back there someday and see what is left. I think there is a cache with half a bottle of Jameson still in it. But I'd really like to go up there to see what was, you know, because I think, as I say here, I think they do deserve at least a decent burial. So, thank you.